Okay, and we are moving on to still right triangles, but looking at what if we aren't given an angle measure, and how could we then go about finding angle measures instead of finding sides? So how do you find missing angle measures giving only side lengths of a right triangle? Again, focusing on solely right triangles, although we will talk about a couple rules today that work for all triangles, in case you run across something, especially on an ACT, where you're solving something that's not a perfect right triangle. So we talked about Unit 1, an inverse statement. And just in general, inverse typically means opposite. So when you're talking about inverse operations, multiply goes with divide, add goes with subtract, sine goes with the inverse of sine, which is going to be denoted as sine to the -1, which you'll talk about negative exponents uh, in Algebra 1b or Algebra 2. I'm not sure where they'll introduce that first, but that has to do with like a reciprocal or the opposite when you multiply your divide. So sine of -1 you'll see on your calculator is above the sine button. So you'll have to hit the shift to get it to go there. But it means arc sine. Okay, so the arc sine of a number. And so that's the case with all of these. We have cosine, which is arc cosine, the inverse of cosine, and then we of course have our tangent. So the inverse of tangent is arc tangent. And usually when I talk about them, I'll just say inverse. Okay. So mathematically, a lot of it is the same. As far as you do a lot of ratios and calculator work. So for example, if we have the tangent of x is approximately 0.7002, we're going to round all these to the nearest degree most of the time, sometimes tenth, but most of the time when we're talking about angles in a triangle, we'll just round up to a degree. So remember I said the tangent and the x are hooked together. That is one thing. So what we need to do, though, is then cancel out our tangent. Well, the inverse operation to tangent is tangent -1. All right, this x does not come off of this tangent until you take the inverse tangent. Well, what you do to one side, you then have to do to the other. So we're also going to take tangent -1 here. So x is approximately the inverse tangent of 0.7002. That you'll type in your calculator. So you'll hit second and then tangent in order to get that functionality. All right, so practice typing that in. You should get x is approximately, technically, 35 degrees. All right, I got 34.999, so round that up to 35. All right. So that pattern continues. Anytime we want to get rid of a trig function, we use its inverse. So here we would do the same thing, the cosine of x, and we could put parentheses up here around this x as well. It means the same thing. We're not going to do anything different. Is approximately 0.9272. All right, so to cancel out that cosine, we take the inverse cosine, or the arc cosine, and what you do to one side, you do to the other. So those cancel out, and x is approximately the inverse cosine of 0.9272. Once again, we type that in our calculator. So x equals, or is approximately 0.9272. 1272, 21.9, which rounds up to 22 degrees. Again, making sure that your calculator is in degree mode as you are solving these problems. Go ahead and practice C on your own. Okay. Continuing that pattern, we can use those same ratios once again to find missing angles if we're given two sides, because remember, these decimals up here that we got earlier are just ratios between two sides. So the sine of x was something over something that has now been divided. All right. So we could use Pythagorean theorem to find AB, or you can use, if it's a special right triangle, you can use your patterns. Sorry. So let's start by finding the side. So we have a squared plus b squared is equal to c squared. All right, so this side is your c. This is either a or b. So we have 4 squared plus b squared equals 14 squared. 14 squared is 196. 4 squared is 16. So we subtract that over, and we get 180. We will square root that. That's not a perfect square root. Alright, I left my figuring out here to the side. 9 and 4 both go in, and they're both perfect squares. So that means 36 goes in. So we take the square root of 36 out, and we're left with square root of 5. So AB is 6 root 5. Okay, that's not a clear, obvious pattern as far as angle measures are concerned. Okay, so to find the different angle measures, we have to set up our trig ratios. So you pick an angle of interest, whether it be A or C. It doesn't matter which one you pick. I'm going to go with A. So for angle A, the sine of A is the opposite over the hypotenuse. The cosine of A is its adjacent, which would be 6 root 5. Over the hypotenuse. And the tangent of A is equal to opposite over adjacent. Okay. Well, I want to solve for A, which means I'm going to use my inverse functions up here. And so I take a look at these, and sine, with its whole numbers and no radicals, is going to be the easiest one to solve. And so the inverse sine of that same ratio is equal to angle A. All right. So you don't have to have that decimal value. You can plug just regular ratios into it. And so I just type that into my calculator. You do want to close your parentheses for this one. So 4 divided by 14, close your parentheses. And I get 16.6. We are again going to round that up to the nearest degree for these. So A is 17 degrees. All right, so this is 17 degrees. All right, to find your last and remaining angle, you could set up another trig function for C, but you could just take 90 minus 17, and that will give you what is left because the acute angles in a right triangle add to 90, and we get 73 degrees. Okay, and then recall what I told you about the larger angle being across from the longer side, the smaller angle being across from the shortest side. That applies here. And so the measure of angle A is 17. The measure of angle C is 73. And AB is 6 root 5. Those are all of the things we were missing from this triangle to begin with. All right, so this is when it talks about solve, it's everything that you're missing. Every side and angle not labeled. Okay? All right, so let's do one more here. So here we have an angle. So as far as what we're missing AB, we're missing BC, and we're missing the measure of angle C. All right, well, measure of angle C is the fastest to find because we can take 90 minus 20, which is 70. Okay. As far as the sides go, we have to use our trig ratios. This is a 20, 70, 90, which doesn't do us any good. And so we would set those up. And again, you're choosing your angle of interest. So I may just stick with the one they gave us. I would do that logically just in case my math was wrong on the first part of the problem. 90 minus 20 is not a hard math problem, but still. All right. So the sine of A is equal to opposite. We don't know, so I'm just going to put BC over hypotenuse, which is 12. All right, the cosine of A is equal to AB over 12. All right. The tangent of A is opposite over adjacent. Since I don't have either of those, that does me no good. But both of these, if I solve either of them, will get me an answer for two sides that I am missing. Okay. And so I'm going to fill in my angle. So I have the sine of 20 is equal to, we'll just call it x over 12. So I multiply this over, and I have 12 times the sine of 20. And I type that in to my calculator. So again, a lot of this is calculator work. Make sure you're set up in the right degree. And I get approximately 4.1. So that's BC is approximately 4.1. Now you could do at this point in time, you could do 4.1 squared plus b squared equals 12 squared. It's not going to be as accurate because this has been rounded. This is an approximation. So it's better to go ahead and use your trig function just to make sure you get the most accurate answer you can. So we have the cosine of 20 is AB over 12. Again, our 12 multiplies over. So we get 12 cosine 20. And we type that into our calculator once again. and I get approximately 11.28. This was 10, that's why I didn't go all the way out to the hundredth. So approximately 11.28. All right, we have lots of decimals in this, and that is okay. All right, so moving on from that, there are two laws, and we're just going to go over one. But this works for all triangles, which is nice. So it doesn't have to be a right triangle. Okay. There's also a law of cosines, if you want to look that up. Okay, so notice there is a capital A and a lowercase a. Capital A is talking about this angle here. This would be angle A or point A. And so that's where our trig functions come in. But you can set this up two ways. You're going to take your sine of your angle divided by the opposite side. That ratio is equal to the sine of another angle divided by its opposite side, which is then also equal to the sine of the third angle divided by its opposite side. Right? You can easily flip all of those over as long as you flip all of them. All right, and don't get lowercase and capital mixed up. Okay, so we would use that when if we are ever not sure that it is a right triangle. So in this example, ABC has a measure angle A is 40, side C is 10, side A is 15. We want to draw a picture and find the measure of angle C. We're assuming that it's acute in this particular case. So I'm going to draw a triangle. I'm not going to make any assumptions about it, but I'm going to label A, B, and C. So I'm going to label the opposite side to A, little a. Here's little b, and here's little c. All right. It tells me that angle A is 40 degrees, so I would label that. Side C is 10, and side A is 15. Okay. I can't assume that this is a right triangle because I have not been told that it is a right triangle. All I've been told is that this angle is acute. So this could also be acute. This could be 90. I don't know. So because I can't make that assumption, I can use my law of sines. So I have big A and little a. So I can set up that ratio first. So the sine of 40, big A over little a. I'm finding the measure of C. I have that, so I know these are equal. So sine C over C. All right, so sine of 40 over 15 is equal to sine of C, which I don't know, over 10. So I want the sine of C, so I'm going to multiply by 10 on both sides. So I have 10 times the sine of 40 divided by 15 equals the sine of C. For these particular problems, I'm going to go ahead and get a decimal approximation for this side. Actually, no, I'm taking that back. We cancel out sine on the C by taking the inverse sine. And so I'm going to do that just to this whole side. Okay. So as long as I'm careful with parentheses, I want to make sure like when it types the 40 in, I end those. I'm going to type it in just like this, parentheses 10, sine 40, close parentheses, divide by 15, close your other parentheses, and get this decimal. Okay, so C is approximately 25.4. Right. If you choose to use, if you have enough information to use this every time, it again works every time. So even with the 90-degree triangles, it would work. So that is another option. You really have to find what method works best for any given problem. So with this one, you need at least 3 things. You would need 2 angles and a side, or 2 sides and an angle in order to use it. With these, you need an angle and a side, but if you have one angle, you could find another, and then use your laws of sines because you know they're right triangles. These are only specific to right triangles. Okay, so lots of different things going on there. Have a good night.